Oh, it's very bright up here. I can't see you anymore. Thank you so much for this invitation to be here. It's a huge honor, and also especially thank you to my colleagues, the people who have presented before me, for such beauty and innovation and setting us up perfectly for this, this talk here. So I'm the founding director of the Yale Center for Ecosystems and Architecture, which convenes interdisciplinary teams. And what we do is we are developing new systems to invent new relationships. We've heard a lot about relationships today, and the relationship between how we set up our associations between humans, plants, animals, and the environment. And we are interested in radically transforming the way that we procure energy, water, food, and materials in the so-called life cycle of the built environment. This is a quick snapshot of the kind of chaos we create in our environment, trying to avoid chaos, and sometimes we create a lot of it too. In essence, what we're doing is we're testing the way in which natural systems function and how we can come closer to so-called nature-based processes for human health and well-being, of course, but also health of the extended ecosystems within which we find ourselves. First, I thought I'd look at the provocation of this gathering, and one of the important terms that is circulating around the globe right now is this term called regenerative design. And just thinking about what that means in relationship to the theme of the conference, it's been pointed out that there are varying definitions of chaos, and prevalent in cultures that are really intent on control is an idea that chaos relates to utter disorder. Unpredictability, yes, but it's considered a negative, it's considered disarray. I thought I'd take some inspiration from this incredible board. We saw these message boards that the students in Ukraine put up, and everywhere we looked, we saw this level of sensitivity and sort of an explosion of creativity. In what it's hard to imagine a more chaotic environment or the conditions within which to produce these kinds of things. So another definition of chaos that is emerging from chaos theory in mathematics of complex systems is the idea that certain systems, complex, interdependent systems that characterize especially, for example, natural or living ecosystems, are highly sensitive to and dependent on initial conditions. That is, that one small change can lead to a huge change in behavior and in conditions in the system. We can see this globally, of course, in our geobiosphere, how we're changing the work of the geobiosphere that has evolved over millions of years, just with very small changes, and the accumulation of small changes. So for us, we would say, just like this billboard, regenerative design actually comes from the smallest of acts that are sensitive to the context, highly sensitive, radically inclusive of parallel agendas, and also ones that can be very resilient to small and large changes. What we're looking at in the systems that we are developing are new ways to look at so-called biocompatibility. And we've heard a lot about biomimicry, and we've heard a lot about bioanalysis, and other terms, or biogenic is another term we heard today from Julian. What we would say is that systems are biocompatible when they foster life and when they foster biodiversity. And so we partner with the architecture, engineering, and construction industries to accelerate the deployment, look at ways to accelerate the deployment through the testing and scaling up of controlled systems in the labs that then get demonstrated. What does designing for biodiversity mean? First, we have to ask how we live. Now, I think actually Athens is an amazing example of a kind of way to live indoor-outdoor. Not all of us around the globe have such an incredible climate as we've experienced today, and I bet it will get a bit hotter and maybe noisier, and maybe the air quality will start to get a little bit worse. So even in beautiful Athens, you might be living indoors, but around the globe in developed cities, we spend more than 90% of our time indoors. This is a tremendous amount. So that is literally the environment that we're all exposed to, the indoor environment largely in developed cities. Of course, in emerging cities, there's a different story, and we want to talk about how we could potentially avoid what we call the dumb 20th century infrastructure that we've saddled ourselves with in more developed cities. But here's an example of where we live, and we can see that really, in comparison, let's say, to the Lenape, which were the indigenous people of the island of Manahara, as we can see on the left here, we're not coexisting with natural systems, obviously, but we do share one thing with the Lenape. The Lenape, like still hundreds of millions of people around the globe, knew how to coexist with their surrounding environments and actually increase biodiversity with the built structures that they put in. But one thing that they share with us, and we can see it with that smoke rising, is that they learned how to burn things to make things, and that's what we have learned how to do over the course of the last several millennia. We burn things to make things. And on the right-hand side, we can see that we're basically burning off-site. We don't see the big bonfire to power Manhattan, but it takes 11,000 megawatts per day to power this environment. And so what we're interested in is really radically re-questioning not just how we might build something new in the future, but how we might radically transform or retrofit the environments we already have, right? Because we have a huge carcass of the city, and there's a tremendous amount of embodied energy, we've heard that term today too, in all of these incredible structures. So how might we actually reconvene with living systems, and why would we want to? Well, the first reason is that we've compromised our immunity by separating from natural systems, and we've also led to very brittle systems, non-resilient systems, systems that actually have very problematic interdependencies. This is a snapshot of the same view that I just showed you after Superstorm Sandy. So this is an example of a quick event that led to rolling blackouts for weeks on end and a lot of flooded infrastructure. So one of the themes that I'll talk about today is how do we actually bring biodiversity back into our environments for more resiliency? There's an incredible set of statistics that are emerging from groups around the world studying this, but there's an excellent group in Helsinki called the Hansky Group that have correlated health and well-being and immunity to the presence of rare flowering plants. What that means is it's not any old green that if we're okay, that if we just reintroduce biomaterials or other things or replace something with another thing, that we'll be okay. It's actually really that we have to let this extremely chaotic, positively chaotic system, which is our extended biodiverse ecosystems and design with. So the first thing that we ask ourselves is how are we building and with what materials? So you'll see the whole range of materials here that we decided to focus on for our UN Global Report. Before going to that, I just want to show, I'm just going to show two complex slides. This is one of them, and I promise I won't have too many complex diagrams, but this is a really interesting diagram for us because what it shows is that up until 1945, the vast preponderance of materials that we had in our global material supply chains were biogenic. So you can see the biogenic materials in green, and then today, well, 2015 is the most recent sort of comparison. You can see that there's a preponderance of high carbon, mineral-based, extractive, non-renewable materials. So materials that the geobiosphere has produced over millions of years, we're taking and we're not really replacing today. So we've heard about circular material economies, and we definitely need to transition, but there's a growing gap between supply and demand. Even if we were to recirculate everything that we have currently in our global built environment, we still would not be able to supply the demand for circularity. Why? Because we have a global building boom. We have a huge building boom where we're constructing roughly the equivalent of the size of the city of Paris per week in floor area around the world. And a lot of this, this construction is taking place in emerging economies that have a chance to really leapfrog over and do things in very different ways. So we were asked by the UN to author a report. We led 30 different authors from around the world, from different areas of expertise, but it is the first time that a UN global report has been led by architects. And we looked at the philosophy of how we might transition the built environment. One of the most important things is life cycle thinking, so basically supporting everyone across that supply chain simultaneously, the material producers, the construction, the designers, of course, all of you in the room, and then of course, even recirculating, maintenance and demolition. But there were three main things that we, and if you're interested in more information on, there's a QR code there on the left-hand side, but the main things were that in very, very well-developed urban environments globally, like Athens, for example, the main thing is going to be retrofit and circularity. We want to avoid waste by building with less and building better and turning our buildings into material banks. So that means designing for circularity and disassembly. That's not something we do today globally, as we all know, but we need to transition with our methods. And we need to radically improve conventional materials because, let's face it, in 40 years, we're definitely going to have steel and concrete and aluminum and all the conventional materials, but we have to radically improve them by decarbonizing the process through renewables and by radically improving the methods, and there's many. We saw some upstairs, actually, during break, and there's so much happening around the world, and so that's really exciting. And lastly, the most controversial thing is a shift to bio-based materials. Now, what do we mean by that? We don't necessarily mean extractive forestry. So what we mean is regenerative silviculture and permaculture methods in agriculture, in forestry, and new radical alliances between the built environment sector, agriculture, and forestry, which I'll show some examples in a minute. But the takeaway, just on the right-hand side of this chart, is that as we start transitioning and removing our dependence on non-renewables, we will have more and more to work with in terms of the global material supply chains and circularity, and we will have more regenerative processes. These are not absolute numbers, these are percentages. So we can't necessarily know exactly how much we're going to be building with in 2060, but there are relationships. This is what would happen if we started transitioning. So another major theme I'm going to go through is how do we understand our relationship to plants and animals? This is an image of many of our collaborators actually do come from NASA and NOAA. Why? Because it turns out that we're learning so much about Mother Earth by trying to put something outside of our ecosystem. And so it turns out that our ecosystem is perfect for our sustenance, and we would not recommend trying to colonize space, but we did learn a lot, and we continue to learn a lot from these kinds of closed-loop environments about how interdependent we are with plants and animals, as I'll show in a minute. So what we do is we associate with very large teams in science, in aerosols chemistry, in plant physiology, in photonics, all of these different areas that come together, and we look at how could we potentially interface and use plants and plant-based processes to clean our air, to clean our water, to be sensors instead of electrical, or mechanical sensors. You can tell so much more about an environment from bacteria that are in good bacteria. We call this yogurt for buildings. It's not, but it is very complex to design with systems because we know that there are reasons that we kept the living systems away. The negative aspects of mold and other unwanted pathogens are always, never far from us. But we are co-designing with species and really looking at how we can replace our mechanical and electrical systems. Also looking at, for example, this is an example of a farm cart in Brooklyn. How much can we actually minimize our footprint and produce our food from very small environments? This is an ongoing program with UNEP called Ecological Living Module, where we are installing small ELMs around the world, which are research, basically measurement devices with our partners to see how far can you go with just 20 square meters for a family of 4 to produce all of the food, energy, water, and air cleaning, et cetera, that you need for that. We don't advocate, obviously, 20 square meters for a family of 4, but that happens to be the size, unfortunately, for the UN High Commissioner for Refugees for families of 4, and the median time that they spend in refugee camps is 18 years. So this is a good opportunity for us to provide more for people who really need a lot. This happens to be in New York City. So wherever you would go in the world, if you were to interface with the bioclimate to produce your food and your energy, the shape, the materials, the means would be different every time. This happened to be in New York where we were not allowed to touch the plaza, and we only had 3 days to build it, so very quick, in and out. And it's showing, though, how biogenic materials can sequester carbon. It's also showing how we can produce energy with new systems. These are new systems that produce basically over 70% of combined heat and power with less than 1% of semiconductor. So it's just, with circular glass and plastics. And then finally moving towards advanced materials where we can eliminate completely the mechanical and electrical. This is looking at the nanoscale, excuse me, on the right-hand side, where architects and engineers can basically manipulate the energy flows just with materials that we cannot see. This is the interior of the ELM. Thank you so much. Sorry, I know we weren't allowed water apparently up here. I apologize. This is also showing a plant system that's cleaning air and water, producing this. So this is just showing what can be done with plant-based means and solar means. Not there's a lot of biochemistry there. There's a lot of sensors and data. But we would do something completely different in Nairobi. This happens to be Nairobi Ecological Pavilion, where we're printing from biological waste, in this case, bamboo, and looking at how we can basically take, if you can imagine, these kinds of robots on the side of a farm or on the side of a forest. You can take from the forest floor. You can take from the farm waste. We have hundreds of billions of tons of farm waste that gets burnt, leading to forest fires globally. But we can upcycle this waste for construction. So this is with Branch Technologies, Shop Architects, who you'll see in a minute, and Oak Ridge National Labs. But we don't imagine this process being necessarily in the lab or even in a kind of factory. We're looking to bring the distributed factories to the sides of forest and farm and then run them through renewable energy, because the things that you really are very costly in our own material environment, in a throughput 20th century material economy, what's costly is labor, time, space, material inputs, energy inputs, all of those things that might actually be free or even a sort of negative liability like the bio-waste on a farm. So another thing, impregnating these materials with thermal, in this case thermal, this is thermoelectric, so it's on-demand heat or cool. Why would you, heat a whole volume or cool a whole volume when you could bring that right to the person? These are our students and our collaborators at the University of Nairobi, looking at reinstalling that at the university. These are coconut core systems, mycelia, this is mushrooms. Our former students, about 25 years ago, actually founded Ecovative, and now they have hundreds of recipes around the world for everything from fashion, for a handbag, to food, grown mushrooms, basically. So how can we grow our buildings? This is forest floor. These are, that's a silk cocoon from the forest floor of Madagascar. And so just looking around the world at all these so-called silvicultural materials or waste materials that come from processes that we can upcycle into different materials that have value. And lastly, I'll just quickly show you what does it mean to actually bring biomass back into built environment. Chris Sharpless from Shop Architects will show you this project, so he's going to talk more about the material systems, but I'll talk quickly about the ecosystem. What does it mean when you go into a system that doesn't have any grid for electrical, mechanical, water, or any other infrastructure? And what happens if it has old growth trees such as this in the savannah? The clients were incredible in this, in really encouraging Shop and the consortium to think about actually not displacing any of the flora and fauna, but actually designing for an intensification of water retention and biodiversity. So this is all designed in and around the existing flora fauna and also creating new opportunities for water retention within the savanna. So you can see very shallow floor plates, and you can see the possibility. This is the solar facade that I just showed you. It's not installed there, but it was designed for that. You can see those clerestory windows poking up above the roof. So in research, a lot of times we parallel track with buildings, and we can potentially have the buildings be evolutionary or be adoptive of new materials as they come online, or as new innovations are ready for those. So with that, I think I will just close by a quick project in New York. We call this, there's also just a quick note out to regulatory. Obviously, designing with living systems is very complex, and it is chaotic, and we have to be very sensitive to that. We call this Mars in the Bronx. This is a big server building. That we would never advocate for a building to be so closed off, obviously from its environment, but it provides an incredible research opportunity for us. So this is many different universities coming together to study the behavior of plants and humans. And one of the incredible things that came out of these studies, and is ongoing, is showing that basically the heart rate variability and the respiratory rates are changing on 20-something subjects, our students literally, within 1 hour of blowing plant-based air in comparison to the control volume, which is the Maserati, or I don't know, Ferrari maybe, of HVAC systems, meaning 100% exterior air and all of the air cleaning. And what we think is, once again, it goes back to this biodiversity hypothesis. We have evolved to breathe biodiverse airstreams, and basically our HVAC systems are antibiotic. They're taking the good out with the bad, and they're basically sterilizing our environments. And so in looking at, using plant-based processes, and this is a solar enclosure for water reuse, so it's also using plant dyes to purify water. Basically, we're looking at having extended open environments, not necessarily closed environments for sure, but in the meantime, as we transition, we can really leverage these building systems to learn a lot about our relationship to the globe and to the natural environments. And I'll just leave you with this image because it is easy to lose hope, and I do agree with the prior speakers about the fact that we cannot let fear and loathing of the uncertainty. We need to embrace chaos, and we need to also especially embrace the inclusion of other systems. So we can look at this image. A lot of times this image is being described by NASA as an image of global light pollution. Another way of looking at this image might be nighttime photosynthesis and CO2 mopping from within indoor environments where humans are living and where plants and animals are welcome. So there's ways that we can actually turn our world upside down and look at it from another perspective. Thank you so much.